AMS has been really a fantastic adventure. In fact, I was there in 1994 at the first meeting between particle physicists and NASA, and we had to learn about the opportunities offered to us by NASA to send an experiment on the space station. AMS is a very complicated project stemming from particle physics experiments, and it had to be organized so that it could not only work on the ground in labs, but also in a very hostile environment of space. And this has been a very difficult technical challenge. Oh, it's a very exciting time. Exciting time first because you see your baby go in a different world. You've been able to work with it, you understand every piece of it, every screw, and suddenly you will go in space and you will not have access anymore to it. So it's a very strange situation where your construction goes away from you. What I find fantastic in this adventure is that it offers a stage for fundamental research. There is such an interest for everybody in the world about space exploration that a project like AMS allows to better understand what is fundamental research and explain to the general public what the scientists are doing. When scientists get together to try to solve some fundamental questions, and here we're talking about fundamental questions like the existence of dark matter or antimatter in space, then scientists can get together, even if they come from different countries, from different regions. They can really work together, and I'm very glad that also CERN was sensitive to that project and played a major role in allowing us to use their facilities. It's very interesting to see that what we are looking for in space, dark matter for example, is also what is being looked at in labs around the world, at CERN in particular, where they will produce hopefully particles made of dark matter, which may be the same particles that we may observe in space with AMS. If we do that, then we will have a fantastic understanding of much of the matter and energy of the universe. We're trying to see how our world has come about. Why are we here on Earth at this time? We probably come from a Big Bang where matter and antimatter have been produced together, and here we are made of matter, and there's no antimatter. So this is a fundamental question that we would like to understand. Yeah, this is a very interesting question that during the time I worked with AMS, I had a time where I was more interested in science policy with CERN, with the University of Geneva. In doing those few years when I was away from the scientific life, suddenly there was a discovery. Much of our world is made of things that we don't see. This has been called dark matter, and you must understand now that we would like to understand what is this much unknown part of the world that we don't see. Cosmic rays are present everywhere, even here, even in the home of every person looking for or working or even being at home. We have to understand a bit more what this is about. Where do those particles, since they are particles, come from? Are they made from accelerators in space? This is the challenge that we would like to understand. Much of the resources that are needed for AMS to put such an experiment in space, in fact, are to use infrastructures that are working on the ground, but are not working yet in space. And we know for sure that space activities will develop in order to understand better our environment, and for this one has to develop new technologies. So much of the work which is done as a pioneer experiment with AMS will be used, I'm quite sure, to develop new ways to understand our Earth environment.